Hey guys, this video is for a quick review of exponent rules and looking at a more difficult problem dealing with all of your exponent rules. This is not to learn the rules, it's more of an overview. So keeping in mind, you will be using the following rules in this problem. You will be using the product rule. Okay, the product rule says that if you have something with the same base and you're multiplying, that's what product means. You're going to take your powers and you are going to add those powers. So a shortcut answer here would be 3 to the power of 9. Okay, that's one rule that you will see. Another rule you'll see is power to a power. And a power to a power rule says that if you have a number with a power and it's raised to a power. So I'm going to use the same one so you can see the difference between this example and this one. You take your two powers in this example and you multiply them. So this gives you 3 to the power of 20. So that's power to power rule. All right, you'll also use the quotient rule. Now quotient means to divide. And I should probably write that underneath so you know. Quotient means to divide, product means to multiply. Quotient rule is opposite. Division is opposite of multiplication. So these rules are actually opposite of each other. So if you have 3 to the power of 5 divided by 3 to the power of 4, if you look, that's divided, that's the opposite of multiplication. If multiplication means that we add our powers and divided is opposite, then our quotient rule tells us that we take our two powers and we actually subtract them. So that means that our answer would be 3 to the first power. So these are 3 of the rules that you will use in this one problem. Okay, I'd like to go over an exponent problem with you so you can see, and this is the most advanced that you'll probably see in this class. So let's start with section by section. So there's going to be three sections that we're going to look at. This one that I've highlighted in orange or yellow, and then this one I'm doing in green, and then we'll look at the third little section, which is not much going on there, in blue. So let's just kind of look at each of them separately. So I'm going to just draw a line. And we're going to do each of these separately and then put them together at the end. So if you just look at the first section, we want to take this power and we want to share it with everything inside the parentheses. So we're sharing it with this exponent or this power, this one, and this one. And that's called power to power rule. So if you remember from your lessons, power to power means that you are multiplying. Okay, so let's do that. So if we do that, we get 6 times negative 2. That gives us, negative 2. That's going to give us 2 to the negative 12. Now we're doing the next one, 3 to the negative 3 times negative 2. So our powers when we're multiplying, or I'll put parentheses so you can see it better, that would be positive 6. And then 5 to the power of 0 times negative 2, which is 5 to the 0. Now, remember this trick, let's write this out actually first. So we're going to put all these together as part of our answer. So this is 2 to the negative 12, 3 to the 6, 5 to the 0. Now what I was going to say is anything raised to the 0 power we know is 1. And 1 times any number is just whatever that number is. So I'm going to cross that out. And we're left with this as part of our next step. So we're going to get back to that in a minute. Let's look at the green in the middle section. So if we look, it's still power to a power. We take the power and we share it to both of these powers. So that gives us 2 to the negative 2 times 2 over 3 to the negative 1 times 2. So on the numerator or the top, we have 2 to the negative 4. And on the denominator, we have 3 to negative 1 times 2, or negative 2. So in a minute, we're going to deal with that as well. Now, if you look at the third box, we're not doing anything to this, so we're just going to leave it to 2 to the 12th. Now we're going to put all of these together. Okay, so last slide we took each section, remember, and we solved for it. So if you look, this first yellow section became this, and we saw that the green middle section, when we shared the powers from power to power rule, became this, and we can see that there's not much to do here. We just brought it down. So now we have all of those simplified. It just makes our life easier. So what I would suggest you do next is we just make a fraction and we put everything on top and on bottom. So when I'm looking at this, what do I mean by that? Well, if you look, these are all over 1. There's nothing there. To make it a fraction, we would put it all over 1. And if you look at 2 to the power of 12, I'm going to put that over 1 as well. So now we have 3 fractions. So if we take all of the numerators, the top, we can put them together. So I'm just taking all the tops of all of these fractions and putting them together as 1. And then I'm taking all of the bottoms. Now on the bottom we have a 1, and a 3 to the negative 2. So those are all of our denominators. Okay, now we're looking at it and we're going to just take it step by step. So on the top of our fraction, our numerator, is there anything that we can combine? So now we're using another property here. And this property says that when we're multiplying, which we are, if they have the same base, you can add your powers. So while we're multiplying, so we have 2 to the negative 12, we have 2 to the negative 4, and then we also have 2 to the 12th. So if we were to put those together, we're adding all of those numbers on the top. That would be 2 to the negative 4. Notice that a negative 12 and a positive 12 will actually cancel out. And so we're left with 2 to the negative 4. All right, so now let's do the other one, which is a power of 3. There's nothing else on the top that has a power of 3, but what we can see is that the denominator has a power. I'm saying power this whole time, and I mean base. I'm sorry. The base is a power of 3. So if the base is a power of 3 and we're dividing, we can take our powers and we can subtract them. So 6 minus negative 2. And when we do that, that's called the quotient rule, we get a big plus sign. Remember, a minus and a negative makes a big plus sign. So that's like 8. So 3 to the power of 8. Now the question is, does that go on the top or does that go on the bottom? Well, if it has a positive power like this does, it would go on the top. Okay, so we are almost done. This is what we have so far. Now we don't like negatives, so if we have 2 to the negative 4, let me write that real quick, times 3 to the power of 8, what we want to do is we want to make sure that our negative powers are taken care of. So remember, if there's a negative power, and this is all in the numerator, this is going to have to be moved down. So what we have is 3 to the power of 8 on the top, and then on the bottom we put 2 to the power of 4, keeping in mind that when you move it down, the negative goes away and it becomes positive. And so we can see here that this is our final answer. We could go farther and actually figure out the numbers, but we can leave it like this. We put all the 3's together and we've put all the 2's together. So this is how you do this type of problem. It's very involved. You're using all of your rules that you learned. But it's a great problem. You just have to look at it piecewise by piecewise and make sure you're okay. If you have any questions, let me know.